Welcome to a lesson with Dr. Powell. Let's take a look at a related rates problem that deals with a conical shape, it's a tank. And suppose this tank is leaking out. So suppose that we let V be the current volume of water, and the rate, let's suppose that's leaking out at a constant rate of -2 cubic feet per second. Also suppose that the whole tank is, the height of it is 20, and suppose that the radius of it is 10. We're also going to suppose that we want to know at least what we would like to know is what's the rate that that the water level is dropping right at the instant when h is equal to 12 feet. Suppose these are feet. Okay, so let's see what we can do with that. First, since we want to relate dv dt and dh dt, we need to have a relationship between v and h itself. So we can have a formula for this, formula for a cone, 1/3 times pi r squared h. So this relates v and h. However, you see the extra r in there. Maybe we can relate h and r together. We should be able to. If we just look at this, notice that the radius of the whole tank is 1/2 of the height. Since we get similar triangle here, we could think of the radius of this portion as always 1/2 of h. So the radius we're concerned with is just h over 2. So we could just think of h over 2 here. And so we end up getting pi 12ths h cubed is equal to v. Now, since we have an equation that relates v and h, that prepares us to get an equation that relates the derivatives. Notice we didn't plug in 12. We wouldn't want to do that because we want the variables completely in order to take a derivative. Otherwise, we get constants with derivative of 0. Wouldn't help us at all. But we do have something that's changing, and so we keep everything as variable if it really is changing, which should make sense. Variableness means variability. They should stay as variables if we're going to take a derivative. So we take a derivative of both sides with respect to t, thinking of v and h both as functions of t. On this side, we'll use a chain rule, thinking of composition here, changing to multiplication, dh dt, and 3 squared where the h pops in here. Okay, so we're going to end up having pi 12ths multiplied by 3h squared dh dt, and that's going to be equal to dv dt. Now, if we assume that dv dt is -2, and then at this instant now, since we have an equation that relates the derivatives, we may as well just plug in, because we have at this instant this, and we can figure out what these guys are at that instant. Because we want an equation with these things, and now at this instant, may as well just plug everything in at that particular instant. So we get -2 is equal to pi 12ths multiplied by 3 times h squared, or so 3 times 12 squared times dh dt, and notice that exponent cancels there. So, we can divide both sides by 2 if we wanted to make that just a nice 6. So we end up getting, so 18 pi, also -1 over 18 pi is going to be equal to dh dt. So that means this is the rate, and it's in feet per second. The water level is dropping right at the instant when the height is 12 feet. Thanks for watching.